Okay, we're going to do some work on tangents and normals. Now, for any smooth curve, the tangent is the straight line that is what the curve looks like if you zoom far enough in. So if you zoomed in on a small circle here, the line I've drawn and the curve would appear to be almost exactly the same. So it's a straight line that shares the same gradient as the curve, and this is called the tangent. And the other kind of line we can draw at a point that has a name is called the normal, and the normal is at right angles to the tangent. So the tangent is the straight line that shares the gradient of the curve at the point, and the normal is the line at that point which is perpendicular to the gradient of the curve. Now we're going to look at these things in the context of circles. So here's a circle, and here's the tangent to it at a particular point that I'll call P. Okay? Now if I draw in the normal, that's the line at right angles to the tangent, and you may remember from GCSE geometry that the line that meets the tangent at a right angle is the line through the centre of the circle. So it's the radius if I go from here, or the diameter if I go from here. In fact, the normal is the complete extension of that line. So, if I'm doing a question about tangents and normals to a circle, if I'm asked for the normal to a circle, it's just the equation of the line that goes through the point on the outside, where I'm taking the normal, and the centre of the circle. So I can use the 2-point method for straight lines. And if I'm doing a question about the tangent to a circle, it's the line that goes through the point P on the outside, but at right angles to the normal, and again I can get the gradient of the normal using the 2-point method for gradients, and so the tangent I'm just going to use the perpendicular gradient for that. So to summarise, if I'm finding the normal at a point P on a circle, then I'm going to be using the recipe for a straight line, y minus y naught equals x minus x naught. So I'm going to need a point and a gradient. For the normal at P, the point is just going to be the coordinates of P, whatever they are. And for the gradient of the normal, I can use the 2-point method for the gradient of this line through P and C. So I'll do the difference in y over the difference in x using those 2 points. So that's how I will do the normal. And for the tangent at the point P, well, once again it's a straight line, so I'll be using y minus y naught equals mx minus x naught, and I need a point and a gradient. And once again I can use the point P, whatever the coordinates of P are. For this one, because it went through C as well, I could have used C, but I said use P. Of this one I have to use P, okay, because it doesn't go through C. Okay, for the gradient I've got to get there now in 2 steps. The first thing I'm going to do as before is the 2-point method to get the gradient of CP, and then I'm going to use the perpendicular gradient using the method of the negative reciprocal. So I've got one more step in the process to work out the perpendicular gradient, but otherwise it's a similar method to the normal. Okay, so that's the theory. You now need to see an example of how that's done.